Cool, so let's just go through setting up the dev environment. There's a guide already on this. I'm literally just going to follow it to the point so you can visually see it. But it's nice and straightforward in IntelliJ, which is what everything's going to be in from here on out. You want a new project, call it whatever you want to call it. Call it test. Sure, that'll do. I'm not going to create a Git repository, but you can if you so wish. We're going to have it Java, Gradle, and then Kotlin, Groovy, whatever. Okay, let's just leave it on Kotlin, sure. Cool. I mean, it's simple as that. I'm not going to change any settings that he hasn't already. So click create. That's loaded this up. We then need to modify the Gradle build, which is what's going to download all of our PowBot dependencies. So copy to clipboard. Let's go back to here. Literally Control A, paste over the top. Done. Oh yeah, I forget mine's slightly different, isn't it? So I'm just going to swap those over. Same with these. Someone's welcome to tell me why mine are different. Sure. Cool, I even wrote it here, look. Cool. Simple as. And once you've updated that, you want to basically load this, you want to run it. So let's just do that. That's syncing anyway. Cool, let's just see what whilst it's doing that. Yada yada yada. Start making your script. Cool, so you're going to want to follow this folder path. So in here he's got org, proto, agility. Cool, we can do that. Cool, it's downloading all the bits we need. Okay, so we don't need example. Let's just go refactor. Oh, wait for it to finish. Nothing here. Huh. Alright, let's just rename this then. Test library. Cool, I'm going to go test library, and in there we've got main.java, which I'm going to get rid of. Just go. Actually, now I'll show you how to do it in here. Right, cool. Test library. We want another new package, and this is going to be test script 1. Cool. Now inside test script 1 is where we get to make our main Java class. It's going to be test script 1. Cool. Right. That's setup done. That is the bare bones basic setup of how you get ready and you get your dependencies set up and good to go. Cool. So we've now got our script created. Or the file created. Now we need to start adding some bits so we can basically start building it. So for starters, there are a few different constructs and ways that people build scripts. I like to do mine as tasks just because I find those much easier to manage, and that's what I'm used to working with. You can use trees or TBLs or tree branch leaves, whatever you want to call them, as another popular way, but I'll be going through a standard task script. So to start with, we need to extend abstract script. Cool. So for really first time beginners, you will have auto prompts So things like these are coming up as suggestions that you can use to autofill, and Tab will just finish it off for you. You can see here it's auto added that import for us, but it has created an error. And all this is saying is just because there are methods that must be added in order for us to extend abstract script, and required methods that come along with abstract script, which is poll. Now, poll is our main looping function that will loop until you pause or stop, or until the client has to have a break or log in for you and all that kind of stuff. And it will loop infinitely until one of those things happens, or until there's an error or something like that. One of the other methods that we'll be using is the onStart, which happens once, literally runs on the start of the script. So you can do things like set variables, you can create task lists, you can check the user requirements, all this kind of stuff. Cool, so that's that. I'll show you running these later on, but I just wanted to show you getting them into the script. We need to actually create a manifest for the script. What's going to tell the client what the name is, what's the description, all the stuff that you kind of see on the script selection side of things, we still need to add. So as you can see, @script manifest is suggested here. It's going to have a name, and it's going to be .tutorial. It's going to be the name I've chosen. Oh, I'll just type it out though. It's my brain. .tutorial. We're going to have a description. It's going to be script tutorial. There are other things in here. You've got things like author. You've got things like category. Let's just go for combat. It's probably going to be a combat script. So combat. Then there are other things in there like setting it private, setting your script IDs and that kind of stuff, but we'll just stick with these for now. Right, now we need to actually create a main method. So the main method is what's going to basically upload the script to the client, because don't forget, the game and the client runs on a separate machine, whether that be an emulator, which is emulating a whole phone separate to your machine, or it's a phone that you've got plugged in, or something similar, tablet, whatever. So we need to have a main method. Cool. Here is essentially an empty main method. You could run this and it'll do nothing. What we need to do is we need to basically upload our script, and one of the library files that was downloaded as part of our Gradle library would have been the script uploader. There are a few different ways to do this. This is the way that I like to do things. There are simpler ways, but again, this is just what I like to do. So basically, we're accessing script uploader. You can see there are a couple of different methods that come along with that, but we're going to do upload and start. It's going to be .tutorial, so this is the script name it's after. Cool. And you can kind of see here, these prompts are telling you what it's after. So it's after a script name, then an account name. I don't have one, so I'm not going to give it one. A device name, which we will go and fetch now, actually. So I'm just going to clear that so we can start fresh. I've already added ADB to my system properties, so I can simply do ADB devices as an example. But what I'll do, I'll show you how to change the we'll start from scratch, and I'll show you how to change the directory to your folder. So first of all, you've got to figure out where your client is saved to. Not your client, sorry, your .powbot folder. So it's usually in C, then users, then whatever your main user is, then it'll be .powbot. From there there'll be an Android folder, and then there'll be a platform tools folder. So then once you found that folder, copy that link or the path, CD, change directory, paste the link in here. This is my link, users Dan, PowBot, Android, platform tools. Now you can see this was the directory where we were running from, and it's now here. So now you should be able to reference ADB because that's the application folder that's inside platform tools. ADB devices, and you can see, cool, it wasn't running, it's now running, there's no devices connected, and I've got BlueStacks already open, so we can go to the settings, advanced, and you can see 5665 is the port that I'm going to be using. 127.0.0.1, that is localhost, that's your local PC. So if we go back to here, and go ADB connect, localhost 5667. So localhost or 1227, you can connect to either of them. And we're now connected. ADB devices to confirm. Cool. This is now the name of my device. That's what I need. Go back to here. Go. This is, again, it's after device name. That's the device name that I've just connected to. Port forward true, and default configs is false. So port forward true. I don't know if it's still needed. I don't remember. It's been a long time, but I leave this true anyway. I don't have any problems. Use default configs. So essentially, if you were to have user settings that you've set default values to, and you can quickly run and test your script with the default values, you can set it to true, and you won't have to populate them. It's nice and simple like that. Cool. So we've connected to ADB. Here's our main method, which you can run. Sorry, I've missed static. Right, so anywhere where there's a play symbol, there's a play symbol there, and there's normally one up here yet, so you can run there. There's play symbols here. You can just click, run. Bada bing, bada bong. This is going to do nothing because I haven't put any outputs in here. But so shorthand sout is a system.out.println. So tab on that, you can go all is running. I'll tell you what, let's just do int I equals 0. So an integer is a whole number. What we're just going to do is we're going to do I plus plus, that's shorthand for +1, I plus 1. Cool, so basically just building a string here that says output poll is running plus the string version, so of the string value of I. So it starts at 0 when it compiles, and then every iteration it pluses 1, so we can see how many times it's run. Let's just do this. Poll is now running. You can see how many times it's running and how fast it's running. Simple as that. That is now your script connected to your device, and we are now running actually on the device. You can see there's stop and play and whatever. I can press stop on that, and it's now no longer running. You can see update is stopped.
Okay, this is the 5th time I've done this. The first 2 were in a different project. The first 2 had broken, messed up audio. This one had no audio. I've just finished this one to find out my audio also did not record. So I'm fuming. Anyway, I'm bored. Let's get this over and done with for the 5th time. Apologies. I'm just going to whiz through this super quick. We need to create our task construct. We call them tasks, but actually we need to create this object type, this entity type of objects that we're going to be creating. Now, what I'm going to do is I'm just going to copy it out of here because I literally don't have the will to type it all out again. Okay, so abstract class task. So we're going to call it task. We're going to reference it to task. We've got a string. So string is just text. And we're going to say name. We want to name one of our tasks. So in here, we've got task, and it's going to have a name. So here are the two methods that's going to come along with it. We're going to need a boolean, which is true or false, to say whether or not it should or shouldn't execute. And then the actual void, so a non-return type method that says whether or not, that actually does the actions. Okay, so really short and sweet. Pause it, copy it, do whatever you need to do. Right, so test script 3. Let's go into, right, so when we create our tasks, we're going to need to store them somewhere. There's going to be some sort of container, some sort of thing that's going to hold an instance of our tasks that we can refer back to and run. So I use an array list. There's probably loads of other ways you can do this. Now, as you can see here, array list is telling you in these little less than, greater than, it needs some sort of input to say what it is. So in here, for example, k and v is key and value. It's just going to be a type that tells the code what type of entity are you storing in this list. And for us, we've just created it. It is task. So we're going to go new task list is what we're going to call it. So you can call this whatever you want. You can call it task tits. Task list is what we're going to go for. Equals new array list. Done. That is a completely fresh, brand new and empty blank list. What we can then do is once we start adding stuff to it, we get to loop our list. So one of the simplest loops you've got in Java is a for loop, which will, so it basically says for each one of these things that you've given to me, I'm going to loop over them and let you do whatever you want to do with it. So what is each thing that we're going to loop over? Well, the type is task, because we've already said that the entities in this list are are tasks. You can give this a name. Again, you can call this whatever you want. It does not matter here. It's just saying create an individual instance for each one of the things that we're going to loop over. And now we need to say, what are we looping over? What are we checking? What are we going through? We're going through our task list that we created earlier. So again, this is this. You can kind of see where you click on it, it highlights. This is task. Again, that highlighted, it's the same thing. And this is completely on its own. It's just completely made up. But it allows us to do things like task.should execute, task.execute. I can't type for shit. I've done this 5 times now, so. Right, so should execute is a boolean, which means it returns true or false. So we can do a check. So an if condition. If this is true, then we want to execute. So if this is true, run. Now, we did mention earlier that we're going to be adding names to our tasks. So we can do some logging to the script. So logs are great for working out what did run and what didn't, what is working, what isn't working, so you can kind of narrow down where your problems are. So the most easiest logging to do is a sout or system.out.println. It's shorthand, you press tab and it will populate it for you. Checking task, and I'm going to do a plus to add on the end of task.name. So again, this task we're referencing here is whenever the current iteration is, again, it's referencing this. Checking that task, and I'm going to copy this, paste it here, and then go running task, task.name. So this tells the writer when they get a load of logs, checking task, should execute, then it runs. If you're stood at the bank, for example, and the user says, it's just idling at the bank, you can see checking task, whether either it does or doesn't run, and you can work out where the issue lies from there. Okay, this is a really, really basic loop, but what will happen is this will loop all of our tasks repeatedly. But if the user stops or pauses the script, it's going to continue looping. So what we want to do is we want to check the script manager if the script is stopping or if the script is paused. So then if it's either one of those, we can break out of this loop. So all break does is it just goes, right, wherever we are in the loop, I don't care, I'm just going to exit the loop straight away. So right, let's get on to writing an actual task then. Oh, that's the wrong one. So create a new package, so a new folder. I'm going to call this tasks. In here we're going to want a new Java class, eat food. Okay, we want to extend our task entity that we created, and it's coming up with an error. So what's wrong with this? If you hold down Alt, so you click on it, hold down Alt and press Enter, it gives you some suggestions. So the first one being we're missing some methods. If you click on that, we're missing the methods we created. So should execute and execute. So click OK and it will populate this for you. So here we're creating the task following this structure basically. So should we execute? When do we need to eat food? Well, firstly, if we have food to eat, right? So inventory.stream. So we're streaming the current data from our inventory. And we know it's current because we're re-accessing the live stream. We want to filter all of the items in the inventory down to just a lobster. Or it could be lobster and a shark, for example. I'm going to check that it's not empty. As it's not empty, as in it does contain something. For the example, I'm just going to be using lobsters, so I'm going to get rid of this second parameter. But do we have lobsters in our inventory? Yes or no? And our local player, which is us. So players.stream is all players, including you. But players.local is only your local player, local to your device. We want to access the local players' game data, and we want to check what their health percent is. So health percent is less than, I'm going to say 90, just because it works out easier for me to show you in game and the script running that it's not waiting for half an hour for it to lose health. 90 works nice for that, but you can set this to whatever you want. In actual fact, we're going to add some user input and allow the user to set that health percent later on. But if that's the case, if we've got food and we've got low HP, we want to cache an item. So this is called caching or setting a variable, whatever. Item, again, give it a name, call it whatever you want. I want to call it some food. Equals, we're going to access the inventory again. Stream, we're going to filter the inventory to any item that has a name lobster. You could do, for example, ID, and do, if you know the ID, so 995, I think, is cons. Or you've got action, so you could actually do action eat and get any item that has the action eat. Anyway, we're doing name for now. So inventory.stream, not name. Right, so earlier on we checked if it wasn't empty, but what we want to do now is we want to have a look for a method that gives us and that returns what we're looking for. So we've set here an item, so we want a method that returns an item. So you could do first or null, and that'll either find you an item or it will give you a null value. However, first is null safe. It will either give you an item or a nil object. Null versus nil. Nils are, null safe, as in they won't crash if you try and reference a nil item, but if you try and reference a null item, you'll get what's called an NPE, or a null pointer exception, and it will then crash and cause you problems and this, that, and the other. So I don't like to use nulls. It's simple, you don't need to mess around with it. You just do your query. The next thing you need to do is if your food is valid. Always check if it's valid before trying to interact with it. If something happens between this line and this line, you cache your food, you then die and lose all your food, you're sat trying to interact with a piece of food that doesn't exist anymore. So always check that it's valid. And, so double ampersand, so I should have clarified up here, double ampersand is and. You could have double pipe is or. But if the food is valid, and food.interact, eat, we can do an output of we ate some food. So we can couple both of these conditions into this if, because if this fails, it stops. It doesn't check both. It checks them one by one, and if at any point any of them are false, it won't move on to the next one. So you could do that, and that will evaluate the entire condition beforehand, but not advised. So double ampersand, it will then do an eat. The joy about interact is it opens the inventory for you, so we don't need to worry about what tab is open. It opens it for you. It checks if you've got single tap on or off. You can actually add in a boolean here. So this false says to the game, we don't want to use the menu. Do not use the menu at all. So if we control and click on this, what action are we looking for? Does it have a menu? Sorry, so just to recap there, you can actually hold control and click on any of these methods, and it will take you to the class documentation in the libraries that we downloaded as part of the Gradle we did earlier on. And it can be quite useful. So here you can actually see what it's asking you for. It's asking you for an action as a string. And do we use the menu? Yes or no? True or false? So you could say, no, don't use the menu. I want you to single click and do the first option that if you were to just tap on it without a menu. And to eat food, that would actually work. That's perfectly fine. So I'm actually going to leave that in place. In the other 4 iterations, I've actually not covered that. But anyway, whatever. So here, yeah, we ate some food. Else, system out, no food valid, or we failed the interact. Cool, right. So what's actually going to happen is this is going to be true. We're going to run this, find a piece of food. Yes, it's valid. We're going to click on it. But we're actually going to spam click, because when you send an action in game, when you click in game, nothing happens until the next tick rolls over. If the tick has just started 1 millisecond in and you click your piece of food, you won't see it eat that piece of food until the next tick rolls over. So what we're going to want to do is to stop it from spamming. We want to do a condition.sleep for 600 milliseconds. And then just wait 600 milliseconds. And in actual fact, that's fucking awful. Please don't do that. No human sits there and goes, oh, I clicked the lobster 600 milliseconds ago. I can now move on with my life. No one does that. It is awful. It creates patterns, really obvious patterns, that every single person who runs the script, and every single time they eat a piece of food, they go, click lobster, wait 600, click lobster, wait 600. It's too obvious. It's too shit. And there's no way to validate it or anything like that. So what you actually want to do is you want to do a wait. And here we're going to say wait for what, and for how long, and for how many times. So wait until our food is now invalid. So this exclamation mark will flip the results of this. So if the food is still valid, then fine, whatever. We want to wait until it's invalid. We're going to wait 150 milliseconds. And we're going to check that 10 times. So here we're going to say, right, click the food, wait until it's invalid for 150 milliseconds. If the food hasn't left our inventory, wait again, and keep doing that check for a maximum of 10 times. If the first time or second time this is true, it'll exit. So a maximum of 1.5 seconds, minimum of 150 milliseconds. So it is reactive. As a person is in game, it's reacting to what it can see. You click the lobster, you react to the fact that the lobster has now left your inventory. And here we don't need to do anything else. It's nice and simple. Okay, so that's eat food. That's eat food done. I'm going to close all these ones that I've just finished doing. Make myself cry. Right, so we've got eat food. I'm going to be lazy and I'm just going to copy this task and I'm going to paste it in here and call it attack NPC. Because what would a fight script be without fighting something? Before I do that, we need to give our task a name. Eat food. So again, we're just following the structure of our task class that we set up earlier. So you can see we set this up. This.name equals eat food. So I like to call mine exactly what the task class is. I've done it before where I've gone, oh, eat food is my file name, but I've called it restore HP because I think I'm clever. And then I don't know, 6 months later, someone reports a bug with eat food or restore HP, and I can't fucking find it because I've called it something stupid. Anyway, call it something relevant, call it something useful, and make sure you stick to your naming conventions. So anyway, let's just copy and paste this again because I've been lazy. Rename this. I'm going to clear this out. Okay, so there's going to be more to this attack NPC task because there's more things to check for. So we need to know if we've got safe, if our HP is safe to do so, we can fight. If we've got an NPC to fight and we're not already fighting something. So as part of this, we want to firstly create a new instance of eat food and check if it should activate. We want to make sure it doesn't need to activate. We want this to be false. And if it is false, it means that our health is high enough to keep fighting. So we can then do if we're not already fighting something. So as we did earlier for our eat food task, access your players' local data. So players.local interacting. So this is what are we interacting with already, and then we can check if it's valid. So here, when you start to interact with an NPC or a player, that's what an actor is basically, an NPC or a player. And as you can see from here, interacting returns an actor. So interacting, we want to know if it exists. Are we interacting with something? Yes or no? We want to make sure that we're not interacting with it. So we flip that. And we want to check if there's NPCs for us to fight. So npcs.stream. We want to only look within a certain radius. So streaming can get really expensive, and by expensive I mean resource and time expensive. I've seen some queries poorly filtered take, I don't know, 1 second, 2 seconds to return, when a good query or good stream can take 0 to 2 milliseconds if it's done well. So set a radius of 15 tiles or lower if you're in a smaller space, or higher if you're in a larger space. Let's bear in mind though that the NPC is actually only loading, I think it's 18-ish tiles away, so it would be pointless to set your filter much higher than that. Yes, okay, it will still help rule out anything that's in the game memory but further away, but there's absolutely no benefit in terms of selecting an NPC when you're going further afield. But anyway, so we want to filter again to something with a name, and I'm going to go for a guard because I'm rocking up in Varrock Castle murking these guys. So within 15, we want to just make sure there is some. So are there any guards nearby? And we can go and fight one. Main issue with that is that will look for any guard, ones that have already been killed and fought already. So we want to add a custom filter to an NPC. You can actually call it anything. You can call it N, A, B, A2, whatever. I'm just going to call it NPC because it makes the most sense when I read it back 6 months later. First, the NPC have their health bar visible. We want to make sure they don't have their health bar visible, because if they do, it indicates they're already in combat. So we want to check if there's an idle, non-fighting NPC for us to select and to fight. Okay. So I've written this now a few different times. So let's just go through it and I'll make the changes as we go along. First of all, very similarly to eat food, we want to identify our target, which is an NPC. So that's the type we want. I'm just going to Alt and Enter import class, and we're going to call it target equals. Oh, sorry, NPC. I'm actually just going to copy this. Copy that. So again, the same as this one. Up here, we did is not empty as a boolean. Here we did first to return an item. Up here we did is not empty as a boolean. Here we want first to return the NPC from our string. Now, so far the big issue with this is that the NPCs in the game memory are not in distance order to you. So you could have one 15 tiles away as the first one and one 0 tiles away as the last one. So we just want to do .nearest. What that'll do is that'll sort the stream for us to pluck the first one, which will be the nearest one to us, which makes the most logical sense for us to be able to go and fight that one. So again, like with the item, we want to check that the target is valid. And if it is, we can then just add some output. Found target.name, and then we can do if target target is in viewport. So viewport is basically means it's visible. We can see it on the screen. It's in our game window. We can interact with it. If it's in viewport, visible target, commencing attack. Oh wow. Sorry, my typing is shocking. Target not visible. Commence finding target. Okay, so there's a couple different ways that people can do this. Normally, you would just do camera.turn to target. So we know it's valid, so that the NPC is loaded in the game. All we need to do is just find it and bring it into the screen, so turn the camera. That's what most normal people would do. You could also do movement.step, step towards your target. What this will do is this will send one single tap to move you towards your target. It goes in a straight line from where you're stood to where your target is, in one tap. It does not path, it does not go around corners, it does not handle objects, it doesn't open doors. It literally just finds the closest tile it possibly can and clicks it. If it's inside your minimap and you can see your target on the minimap, it will click the tile your target is on the minimap. If it's outside the minimap, it will click the closest possible tile on the edge of the minimap towards where your target is. If your target is within I think it's 7 tiles, it will click in game, in the game window, walk here or whatever towards your target, not on the minimap, because most of the time people walking around in game don't use the minimap an awful lot. They'll click in front of them, and it will do its click that way instead. It was just done as a way to try and mimic human behaviour, or not behaviour, but the choices they make a bit more than using the minimap. Anyway, I'm not going to use that because I think I'm already defining we're within 15 tiles, which isn't very far. So I think that just turning the camera to a target should be enough, in all honesty. Which is fine. What I'm going to do, I'm going to do an else on the valid. Go sort target not found. Target not found. Just so it's in the logs. So if anything happens, we as a script writer can come back and see, oh, it seems we found that we should be executing execute return true. For whatever reason, this is not giving us anything. So we can dive into why. Okay, so if it is in the viewport, we need to attack it. So simply we get to do if, much like the food one, where we did the interact, we can do if target dot interact attack. If we attack it, condition dot wait until, as we set up here, we're interacting with something. Let's get rid of those exclamation marks. We want our local players interacting value to be valid. 150, 10. So what we're saying is attack your guard and wait until the game knows you're attacking the guard. Again, this is probably a bit long. It should do it when the next tick rolls over, so inside of 600 milliseconds, but I have a buffer for game lag, disconnecting, all that kind of good stuff. It'll early exit anyway, should we need to, so not a problem on that front. Okay, so this is nice and easy. We'll attack the NPC. We won't spam because we've already added this wait in. The issue though is if we need to eat food, we stop interacting with the NPC. So we'll re-trigger this. The problem being though is we're not necessarily checking the NPC that's fighting with us. We're only picking the nearest one. And obviously for an NPC to fight us, they have to be at least one tile away. It can't be on top of us because then it can't hit us. But the nearest NPC could be on top of us. And in that case, we would actually pick a different NPC to fight other than the one that's already fighting us. And that would look sus. It would be weird. Why would you do that? You wouldn't. So what we're going to do is we're going to actually separate this. So we're declaring the variable up here. We're then going to stream any NPCs that match, or that are, sorry, interacting with me and see if there is any. And then what we can do, if there isn't any, we'll stick to our same target. Now this is errored because there's nothing in here. This is a null value currently, and it's only getting set here. But if we go, yes, there's something fighting me, and I want my target to become whatever is fighting me. Now I've added the nearest filter here, or sort, just in case you're in a multi-combat area and you've got multiple things fighting you, you want to pick the nearest. Again, just normal behavior. You'd find it strange if someone picked the one that's furthest away, or, you know, that's illogical to choose. So that error now goes away, because no matter what, no matter whether this is true or false, the target gets set. Okay, so if something's fighting us, that becomes our target. We'll then attack the target. More than likely, if it's fighting us and it's melee, it's one tile away, so it's going to be in viewport. Unless you're zoomed into your own arsehole at that point. Zoom out, pal. Anyway, attack NPC if we don't need to eat, if we're not fighting something and there's something available to fight. Eat food if we've got food and we need to, because we've got low HP. So I'm actually just going to run this real quick. So I've changed this earlier because I think in this setup I did it as 5665. That's a maxed account, so I've swapped it to a different BlueStacks instance, which is a lot lower level, just so it's easier to run when I'm trying to get it to eat food and show you how it eats food. You know, otherwise you end up waiting for 6 years for me to fight a guard for it to, you know, lower my 99 defense main to it. Anyway, right. Okay, I'm running the script and it's doing nothing. So, funnily enough, the reason it's doing nothing is because we've added no tasks to our task list. Our task list is empty. We need to add task list. So task list.add, sorry, instances of our tasks. So task list.add new eat food. So what we're saying is create a new instance of this and add it to our task list. Control and D on the line you're on will duplicate it, so like that. and then you can just replace this, adding in a new instance of attack NPC. So now here we should be able to actually loop some stuff because our task list is no longer empty. So let's just rerun this. Cool, right, so now it's doing something and you can see it's checking. If I just scroll up in the logs, you'll see running attack NPC, found target guard, visible target commencing attack. And it will just keep doing this over and over. It's currently not doing anything because it doesn't need to. We're fighting something, so it doesn't need to fight something. We've got good health, so we don't need to eat. But I did set it at 90%, so it should eat at some point. I can't remember what level 90% is, but it shouldn't take long. We'll just run this until it eats a piece of food, and you can see how it eats, and it shouldn't spam the piece of food. Okay. I've double checked my audio is still recording, so that's a good sign. Alright, 64. I'm murdering these guys. Well, hey, okay, so we attacked, we ate the piece of food, and then we carried on fighting the guard we were fighting originally. Cool, so I'm just going to stop that. Let's just kill this geezer. Right, so we've now done that. Let's go and walk to the bank, because shit, we're out of food. We've got no food left. So we need to walk to the bank to get some more food. So new Java class, walk to bank. Again, extend our task and implement the methods. And don't forget to do your naming. So public walk to bank super this dot name equals walk to bank spaces. Okay, so when do we need to walk to the bank? Well, basically when we've got no food left. So if our, let's copy that, if we've got no lobsters, we need to hit the bank up for some food. But we only want to walk to the bank if there's no bank nearby. So Bank.nearest.distance is less than 10. Less than 10. Okay, so Bank.nearest, there's always confusion. Bank.nearest will search in the game, loaded game, so the game chunk you're in, for an NPC that has bank options, an object that has bank options, a chest, a bank booth, whatever, only if it's nearby and loaded. Lumbridge is only loaded when you're on the top floor of Lumbridge Castle. Then you can't check if the Grand Exchange is within 10 because the Grand Exchange isn't loaded. It doesn't check every bank in the game, only if there's any nearby entities that have banking options. So if there's a bank nearby, if there's not a bank nearby, and we've got no food, well, we need to walk to a bank. So as simple as, let's just do a shout walking to the bank. Movement, so we're going to access the movement API. Move to bank, as simple as that. That will access the DAX Walker API. It will calculate in the entire game, so the opposite to Bank.nearest, it now looks at the entire game, where all the banks are, and how easy it is to get to a bank. We then do done movement. So what actually happens is the web walker is a blocking call. What I mean by that is when you call move to bank or walk to or anything like that that uses the web walker, it locks you into that call until it's completed or errored. As in, we will activate line 22 and we'll print out walking to the bank. And that'll be almost instant. We'll activate line 23 and that could stick on line 23 for, I don't know, 5 minutes, for example, and it's moving you to the bank. The walker engine takes over, takes control. It generates a path and it will walk you to the nearest, not the nearest, but to a bank that has the cheapest cost to get there. Cost as in cost to process, cost to get you there. Different areas have different weightings in costs. So for example, it will try not walk you through the Dark Wizard's Varrock, It will try not walk you through the wilderness because they'll all have higher weights because they're dangerous, for example. Anyway, that will find us the nearest bank. What this will also do is it will take into account, do we have a draining staff and can use fairy rings? Do we have any teleports? Do we have any jewelry on us? Do we have a home teleport off cooldown? Do we have a mini game teleport off cooldown? And it'll try and utilize those depending on how quick that'll be to get us to the bank. What we don't want to do in this case, we don't want to use teleports. So we want to access a Daxwalker API. We want to blacklist teleports. And you could do teleport.castle wars, because that's a very common one it does, because Castle Wars is the closest bank to your teleport location. What we're actually going to do is do all of them. So values will say blacklist every single teleport going. We only need to do that once, and for the remainder of the script run, it will keep them all blacklisted. So we're saying strictly walk, don't teleport me anywhere. To the bank. Done. As soon as we get within 10 tiles, this will no longer run, but we can then actually access the bank and deal with the rest from there. So let's just add in our walk to bank task. I mean, you can see all of these are the same. I've just rinsed and repeated all of these. So, it's funny how some of the code actually differs every time I write it. And all that means is that you can actually write this one of a million different ways. There's no right or wrong. Okay, so I suppose there's no defined right. There are many different ways you can get it wrong, but whatever. General rule of thumb, if it works, great. Once it's working, you can then work on optimizing and making things cleaner and neater and cheaper to run. Anyway, I'll stop waffling now. Now we want to bank. So, banking. I'm going to extend our task again, implement the methods. I'm going to do public banking super this.name equals banking. Cool. So when do we want to actually bank, use the bank, withdraw shit? Well, when we're at one and we've got no food. So Bank.nearest.distance is less than 10, because if it's greater than, sorry, I'm stupid. If it's greater than or equal to 10, we want to walk to it. If it's less than 10, we want to use it. And we've got no lobsters on us. No lobsters. Cool. So if bank.open, the reason that I don't check if it's already opened before trying to open is that if it is open, it won't retry to open it. It'll return true anyway. And if it's not open, at this point, I want it to open it. So there's no point me doing if bank.open, because there's absolutely zero difference between that and that. Just wasting time and resources. So if we're able to open the bank, it will open the bank for us. And then we can check if bank.stream. So again, we're accessing this stream the same as we do all the others. Checking the name, lobster is in the stream, is empty. Okay, if it's empty, well, we need to stop the script because they've got no more food left. They could have, I don't know, 6 bill worth of gear on them and they end up dying. You know, fighting guards with lobsters, of course. You know, who doesn't have 6 bill worth of gear to fight guards? So we want to output to the logs, no lobsters in the bank. Shutting down. But what I actually also want to do is I want to notify the user visually. Notification.show notification. The same thing. No lobsters in the bank, shutting down. So when someone goes, oh, I keep pressing start and it keeps stopping, I don't know why. Because you've got no lobsters in the bank, that's why. So we want to access the script manager and tell it to stop the script. And then return. What return will do is it will say, right, don't activate any more code below me, just exit this task straight away. Then it will then hit our stopping clause here and break out of that loop. Not break as in broken. Anyway, if we do have lobsters in the bank, we want to withdraw them. Really nice and simple. Bank.withdraw. And you could pass so many different options to withdraw. You could give it the ID, give it the name, you could cache the item like we did with the bank, sorry, with the inventory, and pass the item. You know, whatever you want to do, there's so much. So bank.withdraw lobster, and then you can go, oh, I want all of those, or I want 2, or I want amount dot 1 or 5. In this case, I want all. And what that will do, that will use the all option from the menu and say withdraw them all. But in actual fact, we want to check if it does withdraw them. So again, most actions return true or false from the API, whether or not it actually happened or not. So what it'll do, it'll click withdraw all, and it'll then check to see if the game sent that event to the server, basically, or if the client sent that event to the server. So we can then confirm if it happened. If it did happen, we don't want it to spam withdraw. So we want to do our wait again. And what do we want to wait for this time? So what would you look for as a user when you've clicked withdraw? Well, you'd wait for your inventory stream to have something in it that has the same name as what you're withdrawing. So lobster is not empty. Once we wait, again, I'll give it that. I go 150 for 10 attempts because what's that, 1500 milliseconds, so 1.5 seconds. That's a little bit over 2 ticks. Again, it just gives a bit of a buffer. Cool. So if we withdraw, yeah, that's fine. So down here, so if bank open, at this point, if bank is opened, so here I specifically want to check if it is open. I don't want to reopen it, just want to check if it's open. And we no longer should execute because we've got food in our inventory. We want to do bank.close. And that will just click the X button at the top of the bank window. But what you could also do is input.back. That sends a back input, so your back button on your phone or the back button on the emulator. So what I'm actually going to do, it probably makes absolutely no difference, but just to add a bit of spice, you know, variety is the spice of life, so they say. I'm actually going to say, give me a random boolean, true or false. If it's true, click the X button. If it's false, send a back button input instead. That's all. It just, you might get bank.close every single time. Every now and then you might hit back. Who knows? It should work out roughly about 50-50, but whatever. Okay, so let's add some logs to this. So opening bank, finding bank items, withdrawing items, withdrew, waiting for update. Closing bank. So the only reason why we're checking if it should or shouldn't execute, because if we failed this but haven't stopped, so we've got lobsters in the bank but somehow we just failed to withdraw, we don't want to close, because should execute will still be true, so it'll just rerun. The bank is already open, it'll just retry again. So closing bank. So actually let's just do sales bank.close input.back. Okay, there we go. So just so we can see what method is being used to close the bank in the logs. You know, users might say, oh, it's tapping everywhere, it's going all over the place, until it might be bank.close. Or input.back can also open your logout tab. So it might say, oh my god, you keep opening your logout tab, it's really weird, it's really sus. Then you know it's coming from here instead. Anyway, that's banking. So really simple. You walk to the bank, we get there, we open it, we check if there's lobsters, we withdraw the lobsters, we close the bank. Now we want to walk back to where our NPCs are. Walk to NPC. And just change the name. Right, lobsters is non-empty. But actually, we want to check the distance to our starting location. So what we're going to want to do is actually we want a tile, public tile, start tile equals tile.getNil. Okay, so this is a variable. We've just created a variable. That's just variables. Cool. Start tile. So when the user runs the script, it goes into on start. You can save a start tile to access the player's local information and get their tile. Nice. So start tile. Yeah, so what we can then do is we then get to do something like main dot start tile dot distance is greater than 7. Walk back to the NPC. But you'll notice this is all underlined, none of that auto-completed. It's got no idea what I'm trying to write here because I'm making reference to main, which doesn't exist. So actually, let's make main exist. Main is going to be an instance of test script 3. I'm going to call it main. We're going to end up passing test script 3 to this task. So we get to do this.main, which is referencing this here, is equal to what we pass over here. Main. So you can see how this equals that, and this is highlighted and matches that. So you can now see this is actually populated, distance is corrected, there's no errors anymore. However, when we try to add this walk to NPC, you can see it's actually got an error here. And all that is because we're creating a new instance of this, but actually we've already said here that the instance of this requires an instance of main to be passed, or an instance of test script 3. So essentially we can refer, as we do here, this refers to this main class. So wherever you write this, it refers to the class that you write it in. If I write it in here, it would refer to this. If I write this in here, it refers to this. So we need an instance of test script 3, so I can refer to this. You could do test script 3 or new test script 3. There you go. So that also works, but this is much cleaner. Okay, so now we've got that. We want to go walking to the NPC. Done movement. We don't want to move to bank anymore. We want to go move to main.start tile. Cool. So our teleport's already blacklisted, so we don't need to worry about that. It should literally just do the tile back. Do the path back the way it came, essentially, in short. So right, we've got these in a logical order. Check if we need to eat food. Fight the NPC. If we're out of food, walk to the bank, and then walk back. So they're all added. So what we're actually going to do is we're going to run this script. I think I've logged out. I have. Let's just log back in. Okay, so the script is actually kicked in and auto login beat me to it. Cool. Right. So okay, instantly it's gone. Well, you've got no food, pal. So it's walking me to the bank. Oh, let's try to go up a ladder for some reason. That would just be the web walker thinking that ladder's in the path. But right, cool. It's taken out my lobsters, and now it's running back. So it's identified that start tile where we started. It's not teleporting because again we blacklisted those teleports. And it's now able to run back to there. You should see it should now start fighting stuff too. Cool. Right. Now we're fighting dudes. So that'll just rinse and repeat now. That'll just keep going. We'll attack stuff. We'll eat. We'll run to the bank. I'm not going to go through looting. Looting is very much the same as an NPC. So you want to set your ground item, check if it's valid, if it's in viewport, interact as take, and then if it's not, you want to turn to it. Simple as that. And what we do need to do is actually open this script up to be not so static. What if you want to fight banshees, or you want to fight crawling hands, or I don't know, something for Slayer that you don't want to have to hard code and change the name every time? So we're going to add some user options, and so script configurations is what they're called. So at script configuration, again, it has to be in the same place your manifest goes, above your main class. Give it a name. This one's going to be food type. We're going to have a description, and we're going to call it select your food. The option type, so this determines what kind of configuration you have on your start setup. So it could be a string, it could be text, it could be a drop-down box, it could be an integer, it could be a tile. This one's going to be option type dot inventory actions. You can also have stuff like visible, false, enabled, false, default options, and that kind of thing. We're going to want to have NPC. Select your NPC, and that's going to be NPC actions. We want a start tile, so it's not. So you could actually start it anywhere in the world and have a saved profile that you don't have to just have where the user starts the script. And call that tile. Select your start tile, and fun enough, that's going to be a tile. We're going to also want HP. This is going to be eat at X%. This is going to be an integer, and this is going to have a default value. I'm going to set it to 90. Yes, for you wide-eyed beginners have noticed I've set it to an integer, but I've given it a string. It's just the way the script configs work. Everything is all passed as strings. Even if you were to set defaults for these, you would have a string of JSON input. So don't worry about that. It is an integer. So just to show you, if I try to do that, it gives me an error because it has to be a string. Anyway. Right, so what does that look like? We're going to go run script, and before it just started without any kind of input because there was no options. So select your food. We can select food. We can go use, and it's picked up lobster up there. And you can also see selected lobster. Select NPCs guard. Oh, okay. There you go. Right, so it's picked up guards. It's highlighted them all now. Click to walk around. Walk over here. That's going to be my start tile. Eat at %90. Yeah, that's fine. I'm not going to start the script because actually we've not plugged any of that in. We've created those options, but none of it is being used in the script. We're still hard coding lobster. We're still looking for guards. We're not adding those user inputs to our script. So we need to basically create some variables, and I've listed these variables here, or given an area for it. So public int HP, let's just give it a starting value of 0. Public string food name equals blank. Public public string NPC name equals blank. I'm also going to do public int CB level equals 0. I'm going to record the combat level that we're interacting with. If you're in an area with multiple NPCs of the same name but different combat level, it then allows you to say, well, I only want to fight the shitty ones, or I only want to fight the good ones. I think Anku's, as an example, in the safety password fucking thing, where you get like, you're starting 10k in the boots and shit. I think they've got different levels, so it could be like that, for example. Here we've already got start tile, So all we need to do is access the get option and tell it the name of the option we want, and in this case it's tile. Something to bear in mind, that get option has to match exactly how you wrote the name here. It's case sensitive, it's space sensitive. If you get it wrong and it goes get option on something that doesn't exist, it will crash. So bear that in mind. And those crashes do not appear here because it crashes and then disconnects that instance from IntelliJ. So you won't see those crashes. You'll only see the errors in the actual logcat, in the logs if you were to do them in there, for example. Right, so start tile equals that. HP equals get option HP. Really nice and simple. This is get option tile and returns a tile. Perfect. This get option is an integer and returns an integer. That's an integer. Perfect. However, food name and NPC name are going to come from a potentially list of events. So this will return a list of inventory action events, and this will return a list of NPC action events. So what we're actually going to need to do here is create an array list. I'm going to say, right, what type of objects are going into this list? It's NPC action events. Look here. Let's just call this NPCs equals get option NPC. I think that's what I called it. Yeah. Right. So this returns a list of NPC action events, which is what we've written here. Jesus. If I made this a string, it'll crash because this is not returning an array list of strings. It's returning an array list of NPC action events. We can then check if the user actually selected anything. Is NPCs empty? If it is, we can tell the user. So out no NPCs selected. I'm going to notify them too because we want to make sure the user knows that they've done something wrong. They need to correct it for next time. Notification, so show notification. No NPC selected. Access the script manager again and tell it to stop. Cool. Otherwise, actually, if they have selected something, we're going to assume that the first one they did, they might have done 100 different NPCs. Maybe the instructions weren't clear. But what we're going to do is we're going to create an instance of an NPC action event. We're going to call it user choice equals NPCs.getZero. So something to bear in mind, when you count, you probably count in your head, you go 1, 2, 3, 4, 5, etc. And that is one based indexing. You start at 1. For Java, all of the arrays and lists and maps, they all start of 0-based indexing, meaning you start 0, 1, 2, 3, 4, and 5. So if you have something that has 5 items in it, it would go 0, 1, 2, 3, 4. So index 4 is the 5th item. It can get a bit confusing, but we're asking it to get the first one, and we're going to assume the first one is the one that the user wanted. And then we can actually do NPC name equals user choice dot get name. Now the reason that I've actually cached this get 0 is rather than having to do get 0 twice, I can do CB level and get level. So I've cached it, so it's easier for me to access, or when I say easier, I mean lighter on resources to access the data, and we can set both of these without having to access this array twice. Cool, and that's that. We can now just copy and paste this almost exact for food. Call this items actually. Change this. This is now an inventory item action event. We can call this food or rename it to food. That's what we've got here. Right, so we've got no items selected, no items selected, so the user knows what they've done wrong. Rename this user choice items. We can then just copy and paste. So we're just updating all the different types to now match the inventory ones all. But user choice of get name is still correct. We want the name of the food, in this case lobster. It's going to be food name. So all we've done here is we've just created a bit of a template and just changed the values to meet or match the different entity or type. God, I can feel myself. I've been talking for literally hours of recording all of these. My voice is going. Okay, so we've done HP, we've done start tile, so all that was left was just these two. Yeah, okay, so that's it done. We're now collecting all of the information and saving it so we can use it. In this task here, we created a way for our task to read data from our main class. And that was this bit here where we created main, so we could go main.start tile. So actually, we want to do that same thing with every single task. We want to create this main entity. And then we're going to do the same thing that we have done for this. I'm going to create it in here. Just going to paste it in. Like so. And then we're just going to do this last little bit of this.main equals main. Cool. So we're now able to access main inside all of these. But look at this here. We've now got an error. We've got a problem here because eat food now takes test script 3 as a parameter. So we need to actually say, right, a new instance of eat food, but it requires main. It requires this here, test script 3, to be passed to it in order for us to access it. So eat food can then access main as well. So right, so here we go. Right, let's just stick with this one then. So guard, let's get rid of that. I want to do main.npc name. Guard main.npc name. Cool. So something actually that we also did is we also checked and recorded the combat level of the NPC. So we can now, inside of our custom filter, we can do a double ampersand and check the NPC's combat level is equal to, so double equals is comparing, single equals is setting. You're saying set something to this value or make it equal this value. Double equals is comparing, does it equal this value? Main.combat level. So I'm just going to copy this so I can copy and paste it. Copy that and paste it in there. So we're now saying, is there any NPCs within 15 tiles that have the name whatever, aren't in combat, and have the combat level equal to whatever? Perfect. Eat food. This is a beautiful one. Get rid of lobster. Main.food name. Easy. Get rid of lobster. Main.food name. Walk to bank. Get rid of lobster. Main.food name. Get rid of lobster. Food name. Banking. Get rid of lobster. No lobsters in the bank. Well, it's not lobsters anymore. It could be anything. So let's just do that. Plus that. So we're now saying no whatever's in the bank. No whatever's in the bank. Cool. Swap that over as well. Waiting for blah. No more lobsters. Food name. Okay. So got this. So that should be all of them. So it's, right. So we've got errors up the yin yang because much like walk to NPC, we need to now pass an instance of this, our main class, test script 3, to each of these tasks. Perfect. So now you can see how we've got rid of all of those awful hard-coded strings for like guard and lobster and all that kind of stuff. So if at any point lobster is no longer lobster, We just change it in this one single place of food name. And that's the start to using things like object-oriented programming. Is you create these objects and you pass them around as you see fit. But also, I'm actually going to do constants. The public string attack. I'm just going to build some of these. Eat, drink. Right, so the difference between variables is they vary, they can change, they are not the same thing all the time. Constants do not change, they are what they are constant, hence the names. Variables are written in camel case, so lowercase for the first word and uppercase for the first letter of every word thereafter. So CB level, NPC name, you can kind of see that pattern. These are always in capitals. It's an easy way to define them and to change them, an easy way to distinguish what they are. Right, so why have I written these? So attack NPC, let's get rid of this out of here. Main.attack. Therefore, the only hard-coded bits are these outputs here. It's all automatically done from there. Main.eat. So you noticed actually, or I hope you noticed, I actually created a drink constant, because now we're allowing the user to select any food they want or any item they want to be food. It could also be jugs of wine, Sara brews, anything that's drink, as well as eat. So what we actually want to do is check if our food actions has a drink option. If it contains main.drink, then what? Let's do a string up here and call it item action equals main.eat. So by default, we're saying that the item is probably going to be eat. But actually, if the item does have a drink option, let's set item action equals to main.drink. Then here we can actually do item action instead. That way we could eat if it's got an eat option and drink if it's got a drink option. Don't need the user to tell us. We could infer all of that from the type of option that you've added. So there we go, just a bit of tidying up, and you've got constants, you've got variables separate. You can put these into other classes, but for now I'm not going to. It's just a nice and simple tutorial. And that's it. That is as simple as it gets. We eat, we fight, we bank, we go back and get some more. We've got some user options. We've worked out how to plug those into the script. Yeah, it's a real short and sweet script introduction. So you can use these concepts, have a look at some of the pinned things in the development Discord, the documentation, the some of the example scripts out there. You know, you can now use this to say, okay, all the streaming is pretty much the same. There's not much difference. So you now know how to stream stuff. You now know how to interact with stuff. You know how to walk places. And with that, there's no reason you can't now go and do. I know how to stream, so I know how to find. I don't know. Let's go for what's an annoying thing for people to have to do. I don't know. Let's just fuck it. Let's just go motherload mine for argument's sake. You know how to stream now, so you can stream an object. You know how to walk, so you can walk around. You know how to interact. You can interact with the ores. You know how to check your player data, so you can check your player's animations, for example. You know how to do all of that stuff. You just need to now explore and work out what the art of the possible is. And then before you know it, you know, you'll be writing Zora and Vorkath, or TOA, or Nax, or whatever, you know. It's all these same concepts that are used for those scripts as well. Anyway, that's all